Welcome back to Networking 101. I'm Matt Witmer from Brody Precision, and in this video we're going to talk about TCP and UDP packets as well as ports. So if we go back to the OSI model that we've used previously in this series, for TCP and UDP packets we're talking about layer 4, which is our transport layer, and then for our ports we're talking about layer 5, which is the session layer. So what are TCP and UDP? They are packet types. It's a way of formatting the data that gets sent between devices, and there are two different flavors, TCP and UDP. TCP is the transmission control protocol, and it's connection oriented, meaning that there is a communication that happens at the beginning that establishes a connection between a server and a client potentially, or two different devices. So they establish themselves before information is sent. Also with TCP, there's error checking. There's error checking built into the TCP protocol that checks for whether or not there might have been some degradation in the quality of the data that gets sent across between the devices. And it can see that right at the TCP layer. You don't have to do it somewhere else further up the stack. It also guarantees delivery, meaning if the server doesn't hear back from the client like, hey, I got your message, it will send it again. And because of that, we have a higher reliability with something like TCP than we do with UDP. So on the UDP side, we have no connections. We're basically just broadcasting information. We're sending it out to our client, potentially, but there's no connection that's established at the beginning. We know what our client is, we know what that address is, we're just going to send it data, and we're not going to look for an acknowledgement of the receipt of that data. It has some basic error checking, but nothing like TCP does, and it doesn't guarantee delivery. So if the client doesn't get a packet, the server will continue sending on the next pieces of information. UDP, like I said, supports broadcasting, so it can send out data to multiple addresses at the same time, and we'll talk about why that's important to know a little bit later on. And UDP is also better at handling speed requirements. So if you have a connection that requires the data to get there fast, this is the way to go. Because TCP has more overhead, it's a little bit slower at getting the data across. Because of that, UDP is typically used for things like video streaming, phones, so voice over IP phones that might be in your office, whereas TCP tends to be just about everything else. Ports. Ports allow a device to have multiple servers running at the same time. So instead of just having an IP address that designates where your server is, you can have an additional piece of information that tells the client or the browser or whatever you're using to connect where specifically to look in that IP address for the type of information that you want. An example of this would be something like HTTP. When you type in http://google.com, there's a port associated with HTTP by default. You just don't know it. So that port is port 80, and that basically gets handled automatically for you by the browser. Same thing applies for HTTPS. That has a port assigned to it by default as well, and that's port 443. So when you type in https://google.com, it'll automatically use port 443. And then if we look down our table here on the right, we have some other ports that we're probably a little bit more familiar with, Fox, FoxS, and our platforms, Platform Secure and regular platform. So for our Fox and FoxS, you'll notice we're using two different kinds of packets. We're not just using TCP like our HTTP connections are. We're using TCP and UDP, and that's because the Fox protocol supports discovery. And in order to have discovery work properly, we need to send out broadcast packets on our network so that we can find devices that maybe we didn't know were there. And they can respond to that broadcast packet and say, hey, I'm here. So that's what the UDP function of those two do. But by and large, Fox and FoxS both rely on TCP. Platform, there's no broadcast function built in there, so we're specifically talking about TCP. And then BACnet IP uses broadcasts for just about everything. Well, not everything, but it uses broadcasts a lot. Again, we have discovery. So UDP and speed is a requirement here too. So UDP is the packet type that's used. Another thing to note is when you pull up a BACnet IP port on a Jace, for instance, or a supervisor in Niagara, you'll note that the port is listed as BAC0. That's just a hexadecimal notation for the port that's used for BACnet IP, and that port in normal writing is 47808. I guess another thing that's worth noting is in the browser, if you want to use, or not even the browser, most places, if you want to use a port and define a port for something other than the default, you can use a colon and then that port number to give it that information. It's also worth noting that if you're trying to get to HTTPS and you're using a non-default port, you'll need to put HTTPS at the beginning. Otherwise, your browser won't know that it's HTTPS. It'll figure that it's HTTP. A common error that you'll come across a lot, maybe in your workbench on your machine. In my case, I see it a lot on my computer because I've got a bunch of different things running. One thing is this fail to bind to port error message. And in this case, what this means is that another software program on my computer is using port 443. And the way ports work is only one program can attach itself to a port at a time. We call that binding. So in my case, something had already taken port 443, so my station was throwing an error in my application director that 443 could not be bound by my web server. So how do you find out who's using your ports or what's using your ports on your Windows machine? You can run a netstat-ab command from your command prompt, and it'll list out all of the ports that are being used, what protocol is being used, TCP or UDP, and the program that's using them. So in my case, if we go here to 443, we can see it's VMware host D, and VMware is a virtual machine program, and I happen to be running their workstation software on my machine at the time, and that's what had grabbed port 443. So just a helpful thing to note if you run into that error message. So that does it for everything on TCP and UDP, as well as ports. In our next video, in our final video in the initial series of Networking 101, will be remote access and VPNs. Thanks for watching.